Hey, 7th grade. Today we're going to be talking about constant of proportionality. So make sure you have your notes packet open up to the page that says 1.6 constant of proportionality. So first, what is a constant of proportionality? It's simply a constant ratio or that unit rate of two variable quantities. So really, when we're finding constant of proportionality, we're simply finding the unit rate of our ratio. So, for example, if we're given a ratio 90 miles in 3 hours, and we want to find its constant of proportionality, we want to start by finding its unit rate. So we know we're going to do 90 miles over 3 hours. And to find a unit rate, we're going to do our numerator divided by our denominator. So when we do 90 miles divided by 3 hours, we end up with 30 miles in 1 hour. Now, when we write it as 30 miles per hour, we're writing it as a unit rate. To write it as its constant of proportionality, which we typically abbreviate as COP, we simply take that unit rate, 30 over 1, and we write it without its labels, and we can simplify it to a whole number. So our constant of proportionality is 30. All right, we can also see our constant of proportionality in a table. So go ahead and let's make a table in our notes where we have our hours compared to our miles. And we know from our unit rate, 30 miles in 1 hour, that we can start with 0 hours. We would travel 0 miles. In 1 hour, we would travel 30 miles. In 2 hours, we would travel 60 miles. And in 3 hours, 90, and so forth. So in that table, we can see our constant of proportionality is where our hours is 1 and our miles is 30. Now, when we write that constant of proportionality, we always want to write it as our y over our x. So instead of saying the ratio 1 over 30, we always want to say 30 over 1 is our constant of proportionality. Now, let's think about this in terms of an equation. So yesterday we talked about writing equations where we're going to do our unit rate, 30, times our number of hours is equal to our total miles. So our constant of proportionality is the number that gets multiplied by our hours. Now, also think about this in terms of x and y, right? Hours is our x, miles is our y. So we can say 30 times x is equal to y. And again, we see our constant of proportionality is 30. All right, next let's move over to that graph. So when we graph this, we're going to put our hours along our x-axis and our miles along our y-axis. And then we can add in our numbers there. We have 1, 2, 3, 4. Make sure you're making your graph with me in your notes. And then we'll go by 30s. We have 30, 60, 90, 120, and so forth. So we know we have 0, 0, 1, 30, 2, 60, 3, 90, 4, 120, and so forth. So here's our graph. So to find the constant of proportionality on a graph, we're going to look for when x is equal to 1. So in this case, it's right there at 130. So on the graph, look for x equal to 1. All right, so let's go ahead and let's look at an example here. So example 1 says the distance Marissa and her family traveled on vacation in relation to the time spent driving is shown on our graph. So is this relationship proportional? Why or why not? So take a minute, think about if this is proportional or not. Look at our graph and think about what it has to have to be a proportional relationship. Hopefully you were thinking that a proportional relationship should be a straight line through the origin. And our graph is definitely a straight line, and it goes through our point 0, 0, so this is proportional. So what I'm going to say for question 1 is I'm going to say, yes, this is a proportional relationship because we have a straight line through the origin. All right, next let's take a look at B. Explain what the points 0, 0, 2, 120, and 4, 240 represent. Well, we know 0, 0 means we have 0 hours and 0 miles. 2, 120 means 2 miles, 2 hours, sorry. 2 hours and 120 miles. And then 4, 240 means in 4 hours, we have 240 miles. So the next thing we want to look at is we want to look at our constant of proportionality. So if you look really closely at our constant of proportionality, I notice that it's this dot right here. But the problem is that isn't exactly on a number. I don't know if that's maybe 60 or 65 or somewhere around there. So what I can do is I can use other information to help me. So what I notice is I notice that this point right here, 5 hours and 300 miles is exactly on that point. So let's go ahead and let's use that. If we have 300 miles in 5 hours, if I find the unit rate for that, I notice that the unit rate is going to be 60 miles over 1 hour. So that means my constant of proportionality is equal to 60 because our constant of proportionality is simply that unit rate without those labels. So question D, write an equation to show the relationship between time t and distance d. So we know our total distance is going to be equal to our constant of proportionality, 60, multiplied by our time. So we're going to write the equation, d is equal to 60t. All right, let's do questions 2 and 4 together, or 2 and 3 together. For questions 2 through 4, we're going to determine whether we have a proportional relationship or not. And then if it's proportional, we're going to find the constant of proportionality. So one thing I want to point out when we find constant proportionality is instead of finding our ratio as 25 over 100, we always want to do our y over our x. So I'm going to instead look at my ratios here. As the first one, I'm going to say 100 over 25. And we're going to simplify that because remember, to see if it's proportional or not, we want to see if they simplify to the same ratio. So 100 over 25 is going to simplify the ratio 4 over 1. Then we have 120 over 30, which simplifies the ratio 4 over 1. And then we have 140 over 35, which is going to simplify to 4 over 1. And lastly, we have 160 over 40, which also simplifies to 4 over 1. So, yes, this is a proportional relationship. Now, since we put all of our ratios as x over y, this is our constant of proportionality. So, yes, this is proportional, and the constant of proportionality equals 4 over 1, which is the same as just saying 4 as our constant of proportionality. All right, so let's do the same thing for number 3. So in number 3, we know to find our constant proportionality, I'm going to do my y over my x. So I'm going to say 50 cents over $5. And that's going to simplify to 10 cents over 1. Then we'll do the same thing with 80 cents over 8, which simplifies to 1/10 over 1. And $1.10 over 11 simplifies to 1/10 over 1. And then same thing with $1.40 over 14. That simplifies to 1/10 over 1. So yes, this is also proportional, and our constant of proportionality is equal to 1/10. Now, notice how we could have simplified all of our ratios by doing 5 over 50 cents and $8 over 80 cents. That would still give us the same ratio, but if we need to find our constant of proportionality, we're going to save ourselves a little time, and we're going to start with that y over x, because that's always how we write our constant of proportionality. If I accidentally had these flipped, like in question number 2, and I said 1/4, that's not my constant of proportionality. That's written backwards to be the constant of proportionality. All right, what I want you guys to do now is go ahead and flip to the next page in your notes packet, and I want you to work on those questions about constant of proportionality. Keeping in mind, constant of proportionality is just a fancy vocab word for the unit rate. Just make sure if you're looking at it in a table or in a graph that you're always doing the y value over the x value so that you write your constant of proportionality as the correct ratio.